Welcome to Understand the Math. In this video, we are going to learn how to solve exponential equations. We'll look at two common types of examples, one where we make the bases the same, and another where we use logarithms. We'll go through each method step by step so everything is easy to follow and makes sense. Let's start by looking at some examples where we're going to solve exponential equations by making the bases the same. To make things easier, I've written down two steps that we can follow when solving this type of equation. The first step is to write both sides of the equation in terms of the same base, and then the second step is to just set the exponents equal to each other and solve the equation. Let's walk through some examples and see exactly how this works. In our first example, we're going to solve 16 raised to the x minus 3 is equal to 2 raised to the x. The first thing that we want to notice with this equation is that we can write both sides of the equation in terms of the same base. So let's go ahead and let's do that. 16 is 2 times 2 times 2 times 2. So that's just 2 raised to the fourth power. And then it's raised to the x minus 3. And on the right-hand side, we have just 2 to the x. Let's go ahead and simplify the left-hand side. When we have two exponents, we multiply them. So our left-hand side becomes 2 to the 4x minus 12. And then our right-hand side just remains 2 to the x. The second step that we listed above is that we're going to take the exponents. Let me go ahead and highlight them. It's this one and this one. And we're going to set them equal to each other and then just solve for x. We have 4x minus 12 is equal to x. Let's pull the x to the left and the 12 to the right. And that gives us 3x is equal to 12. And then we'll divide by 3. And we get the answer x is equal to 4. And that's the solution to our equation. Let's now look at another example. In our second example, we are going to solve 9 raised to the 3x minus 2 is equal to 27 to the x. This one is different than our first example because notice we have a 9 and a 27, and 27 can't be written in terms of 9. So what we have to do is we have to rewrite both sides of this equation in terms of the same base. So we're going to look at what number is a factor of both 9 and 27. That factor is going to be 3. So we're going to start in our first step and we're going to write both sides of this equation in terms of 3. 9 is 3 squared. So let's write that down. And that gets raised to the 3x minus 2. And then 27 is 3 times 3 times 3. So that's 3 cubed. And that gets raised to the x power. Now we're going to simplify and multiply our exponents. On the left, we have 3 to the 6x minus 4, just multiplying both of those terms by 2. And then on the right, we have 3 to the 3x. You can now see that each side is in terms of the same base, so we can equate the exponents. So let's go ahead and let's do that in our second step. We have 6x minus 4 is equal to 3x. Let's bring the x's to the left and our constant 4 to the right. So we're going to subtract 3x, so that gives us 3x on the left, and then 4 on the right. Then we're going to divide by 3, and we get x is equal to 4/3. And that's the solution to our equation. Let's now look at some examples where we can't write each side of the equation in terms of the same base. The second set of examples of exponential equations that we're going to look at has to be solved using logarithms. We need to use this method when both sides of the equation can't be written in terms of the same base. Just like I did for our first set of examples, I've written down some steps that we can follow, and they're a little complicated, so I'm going to walk through these one by one as we work through our examples. The first example that we're going to look at is to solve the equation 2 times 3 raised to the x plus 2 power is equal to 14. Let's look back up at our steps and look at our first step. Our first step is to isolate the exponential term. Notice in our equation that we have a 2 multiplying our exponential term. So in order to isolate our exponential term, we have to divide by this 2 and just get the exponential term all by itself on the left-hand side. So let's go ahead and do that. We have 2 times 3 to the x plus 2 is equal to 14. And we're going to divide both sides by 2. And that gives us 3 to the x plus 2 is equal to 7. So our exponential is isolated all by itself. Let's now look back above at our second step. Our second step says to take the logarithm, either the common log or the natural log, of both sides of the equation. Let's go ahead and let's do that. I'm going to choose to take the log for this one, and then for our next example, I'll take the ln. We have log of 3 to the x plus 2 is equal to log of 7. Let's look at our third step. Our third step says to use the power rule to bring down the exponent and solve the equation. That's the whole reason that we took the log, because you can use that power rule and get the variable out of the exponent. We're going to pull down the x plus 2. So we have x plus 2 log 3 is equal to log of 7. We want to isolate the x term, so I think it's easiest to go ahead and just divide both sides of the equation by log 3. This gives us x plus 2 is equal to log 7, all divided by log 3. Now we can go ahead and subtract 2. We'll go over here to the right. So our x is equal to log 7 all over log 3 minus 2. And that's our final answer. Let's now look at our second example. This example is different than the first because notice that we have an exponential on both sides of the equation. Let's go ahead and walk through our steps. Our first step is to isolate the exponential term. In this problem, there is no constant multiplying our exponential term, so our exponential is already isolated on both sides, so let's just write down done. We actually didn't have to do that. Our second step is to take the log of both sides. Let's take the natural log just to get some practice with that. On the left, we have ln of 2 to the 3x plus 1, and on the right, we have ln of 14 to the x minus 2. Our third step then is to use the power rule and pull the exponent out in front. On the left, we have 3x plus 1, ln 2, and then on the right, we have x minus 2 times ln of 14. Now what we have to do is solve for x. When I taught this in class, my students always thought this was a little bit difficult because there's a lot of algebra going on. We're going to go through this slowly so it's really clear. On the left-hand side, what we're going to do is we're going to multiply each term by ln 2. This gives us 3x ln 2 plus ln 2. And then on the right-hand side, we're going to multiply our natural log 14 by x and minus 2. So we have x ln 14 minus 2 ln 14. I'm going to go ahead and highlight x because that's what we're going to be solving for. We can move our x's to the left or we can move our x's to the right. I'm going to choose to move our x's to the right-hand side so that our constants are positive. On the left, we have ln 2, and then we're going to add 2 ln 14. And then on the right, we have x ln 14 minus 3x ln 2. Hang with me, we're almost done. The left-hand side stays the same. ln 2 plus 2 ln 14. And then on the right, we can pull out an x. And then what we have left is ln 14 minus 3 ln 2. Now we just have one more step. Let's highlight our x again. To solve for x, we're going to have to divide by ln 14 minus 3 ln 2. And when we do that, we get x is equal to ln 2. I'm just switching sides here so that our x is on the left. And then we're going to divide by ln 14 minus 3 ln 2. And that's our final answer. And that's it. Here's a few things to keep in mind. When you're solving exponential equations, start by checking if you can write both sides with the same base. That's the simplest method. If not, isolate the exponential part and use logarithms. Just take it step by step, and you'll soon be able to solve these types of equations on your own. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.